Welcome to my YouTube channel, and today we are going to be looking at the Dijkstra algorithm. Now, what is this algorithm all about? So basically it's an algorithm that allows us to find the shortest path between distances. We could say, for instance, in this video I am going to be showing I am going to be demonstrating the shortest paths between different airports. So for example, we are going to be saying what is the shortest path between London or Canada, and we are going to be putting all of that information. So let's just dive right in. So what we have here is a function, and that function of course holds our data list, and we set that to an empty dictionary. And then the next thing we want to do is that we want to have an add data. Now this add data, what it is going to do, it's going to allow us to actually input the airport. So depending on the airport you want to input, and how we are going to just be doing this is that we are going to be calling the data list, and we are just going to be passing our data there. And we want to set that to an empty array. And then the next thing we are going to be having is the add edge. So we can say maybe something like the edge could be something like an airport, right? And within this, we are going to be having the source destination. So like I mentioned, the airport and the destination, so the arrival destination that you want to go. And of course, it's also going to have the kilometer parameter as well. We're all going to be passing those three arguments in our add edge method. So we are going to be saying, so if source in data list and destination in data list, and what we just want to do is that we just want to append, and we want to append our data list to our destination and kilometers. So how we are going to just, it's an error there, I'm just going to correct that. So self dot data list. So we are just going to be saying self dot data list, and we also want to pass that into our source. Yep. And then we want to append that, and we want to append that to our destination as well as the kilometer parameter as well. And we want to repeat the same thing for the destination. So we are saying dest, and we also want to append that, and then we are going to be appending that to the source and 2 kilometers as well. So now the next method we want to create is the get neighbors. And what this get neighbors function will do is just to hold the entire data list. So basically it's just gonna have the data as an argument, and we just want to return the data list. So we're just going to be saying self.data list, and we're going to be putting our data in an array as well. Now we want to create our Dijkstra function. So like I said, the Dijkstra will have 3 parameters, which will be the graph, the start, and the end. Now what this does is that it initializes distances from the start node to all other nodes as infinity. And we can just create, so I'm just going to put a comment there, what I said. It will initialize the distance from the start node so to all other nodes. So basically it's going to find the distances between the different nodes, and then give a result to, and then have a result as give the shortest path as the result. And that is the whole idea of this function, and that's what we are going to be implementing. So so we have that as so we're just going to use a for loop to loop through our graph.data list. Then we are going to have in our distances, and we don't want to initialize it to start. Rather, we want to actually just put that as start and initialize it to 0. So the next thing we want to do is to create an empty dictionary to store the shortest part, right? So we're just going to be saying shortest part is equal to an empty dictionary, and this will just store the shortest part. So yeah, equal to an empty dictionary. Now, the other thing we want to do within this function is that we want to initialize a flight part queue to actually store all of the distances from the start node. So we are just going to be having a variable called something like flight part queue, which is easy to remember. So we're going to be having flight part queue, and we are going to be setting that to 0 and start. Now we have our flight part queue variable, but we want to use a while loop. So we are going to be saying while our flight part queue, and we are going to be having two variables here. So we're going to be having the current distance and the current data. So we're saying that if the current distance and the current data is equal to the minimum flight part queue, what we want to do is to actually use a method called a remove method to actually remove that. So because we know that we are set our distance to be at 0, so we want to actually make sure that our current distance will be greater than the distances, since we set our variable distances to be 0. So that is just the next. So we can just say something like, okay, so current. So we could just say something like, if current distance will be greater than the distances that we know is already 0, well, we just want to continue. And so, yeah, so we just want to continue. So now we would be using a for loop. So we could say something like, so for neighbor, we could give a variable called neighbor, and then we want another one called kilometers in graph. So basically, we are going to be using a recursion here. We are going to be calling the method get neighbors. So we can say graph.get neighbors, current data, because remember in the method we have a data list there. So then we are going to be saying we just want to be able to concatenate our current distance and the kilometers. And of course, we are going to be storing that in a variable called the distance. So the next thing we want to do is, well, now we have our distance. So we want to say, well, if the distance is less than the distances, which remember was at 0, well, we want to pass that as our neighbor, because remember, the whole idea for the Dijkstra algorithm is to find the shortest part. We want the shortest part. So we want that to be less. So so now we are just gonna have now we can say, well now we have our shortest part, and we want that shortest part to be the current data. Now we can just append the flight part. Now we can just, okay, yeah, so we want that to be the current data. Now we can just append our flight part to our distance and our neighbor. So basically what this algorithm, what this function has done is that it has actually looped through. We have been able to get the shortest part based on using the less than operator, and that has given us the shortest part. And now the next thing we want to do is to actually construct the shortest part from start to end. So we are just going to be setting our part to an empty array. Now we want to initialize our end, and we would just set our current data to equal to end. And using the while loop, we can just say, well, while current data is not the start, because remember, we already have the start. So now we want to just insert this current data, which is the end for the function. So we can just set that to part.insert, and then we have 0 and of course the current data, and we would have current data equal to shortest part, and of course we want to pass in our current data as well, and we have part.insert, and we also want to have 0 and start as well in there. Now what we want to return is that we want to make sure that we are returning our part and the distance, but this distance is actually the end. So basically, just to recap, we've got our function takes in our Dijkstra algorithm function. It takes in our graph, it takes in our start, and takes in an end as argument. Those 3 arguments. So now we've created the start, now we've created the end. Well, now it's time for us to use our Dijkstra algorithm function. So I'm just going to have that variable called a flight graph, and I'm going to be calling the graph. And now I can use my add data, and now I can just add in any data. Remember, this would just take in I'm using London. Well, to save time, let's just copy and paste this, because it's just me repeating the same thing. And the add edge, so the add edge is, remember, it takes in 2 arguments, which is the source, the destination, and the kilometers. So that is just what I've done, populated that data already. So now we want to see how the Dijkstra function actually works. And remember, the Dijkstra function will take in, so we want to know the shortest part between London and Denmark. So let's see how our function works. So let's see what it's going to tell us. So what is going to give us the shortest part between London to Denmark. And we want to just print, and we want to print, well, something like, what is the shortest part between London and Denmark? And also, we also want to print the distance as well. So we also want to know the distance, because that is also useful. That's also useful information as well. So we want to have another print statement, and that we're going to say distance in kilometers, and we can just pass in our distance variable that's been created. So that is how the Dijkstra function works. And now I can save my script and I can run it, and in my terminal I can see that the shortest part I would have to go through Belgium before I get to Denmark, and it will be a total kilometers of 2,900. So which is really, really awesome. And always remember, you can use this function to create different things that you want to find within, if you want to find anything, find the shortest part between anything. And that's what this function is all about. Thank you for watching. I hope this was helpful. Thank you. Have a great day. Bye.